Today's lesson, where we're going to be resuming our knowledge of applications of arithmetic series and geometric series. We're going to be starting off with question 4 from page 42. A lamb grows by 2/5 of its previous growth each month. If a lamb is 45 centimeters tall and starts growing by 2/5 of its height, how tall will it be after 6 months? So, let's start off by thinking that this lamb is basically 45 centimeters tall, and after 1 month, the lamb will grow by 2/5 of its height. So, what does that actually mean? That means that the lamb will now be 45 plus 2/5 of itself. So basically plus 45 times 0.4. Right? Now, if I do that on the calculator, that gets me basically 63. Okay? Then, what we're going to do is we're going to grow this lamb by 2/5 of its previous growth each month. Okay, this is the hard bit to understand. 2/5 is 0.4. Okay, sorry for not addressing that earlier. 0.4 is the 2/5 here. Now, previously it grew by this much. If we're going to grow the lamb by 2/5 of this, okay, which is the previous growth, we're going to times this by 0.4 again. Okay, meaning that we're going to add 45 times 0.4 squared, and that will get us 70.2. Now, if I then add the 2/5 of this, which is 0.4 times of this, I will have 45 times 0.4 cubed, which will now get me 73.08. Okay, and I'll repeat the process. Okay, again and again and again. So it's going to always increase by 40% of its previous growth. Okay. Now, when do you actually stop? Well, this is after the first month, second month, third month, fourth month. But 2 more times. Okay, this is what you get after doing that. Now, I gotta do this 1 more time. Okay, so I'm going to add 45 by 0.4 to the power 6. Okay, let me just try that out. Okay, now that will get me 74.87712. Okay, so this answer is actually wrong. Okay, don't worry about that. Our lamb will be this height. Okay, so rounding that to maybe just 2 decimal places. Okay, we can say therefore the lamb will be approximately 74.88 centimeters. Okay, right. Then we can have a look at question B. Okay, now what will its final height actually be? Right, so let's have a look at what's actually happened. We started off with 45. We added 45 times 0.4 to that. Then we got this answer, and then we kept adding this, all the way to the end. Okay, it keeps on growing. But you can see that when it grows, like the difference between these two is like around 7.2. Then this will be around 2.88, and then it gets less and less. Okay, grows less and less, and that actually makes sense because a lamb wouldn't grow more than its previous height. Okay, it shouldn't. Okay, so it grows a lot more during its younger years, and then when it gets older, it's only going to grow just a little tiny bit every single month. All right. So, question B is saying, what is its final height? Okay, so which means as time goes by, eventually, what is the limiting sum? Okay, of all of this. Okay, so it's going to add all of these numbers here to that original 45. So let's start by writing t, okay, of infinity, first of all, okay, will be 45 plus 45 times 0.4 plus 45 times 0.4 squared plus 45 times 0.4 cubed plus 45 times 0.4 to the power 4, and so forth. Okay? Now, the thing that we have to do now is we have to sum all this. The starting value is 45. We're going to leave it as it is. But we can see over here that this can factorize. We can factorize 45 times 0.4 out, giving us 1 for the first term, if we factorize that out, plus 0.4 for the second term, if we take 45 times 0.4, and then 0.4 squared for the next one, and so forth. Okay, so it's going to keep on going. All right. Now, the reason why I wrote t infinity, okay, t is basically the height of this lamb. Okay, infinity just means that these are just going to keep on going. Okay, so we're going to assume that this lamb will keep on growing, but it will be very, very small increments as time reaches infinity. And you can see that because once we factorize this out, look at this series here. What kind of geometric progression is this? We can see that the ratio here is 0.4. Now remember, when this ratio here is between -1 to 1, then this series that is apparent here, it would be a limiting sum. So eventually this is going to converge to some value. It's not going to grow any higher than that particular value. All right? So let's write down the beginning parts of it. So the 45 plus 45 times 0.4. We're going to times by the sum of this, which we're going to use the limiting sum formula for, which is a over 1 minus r. So that would be 1 for the first value over 1 minus r, which is 0.4. Okay? Now, by doing this on the calculator, I do get 75 centimeters. Okay, which is very close to what the height of the lamb was really after the 5th month. Okay, it was already approaching 75, so the lamb was already capping its height. Okay, right. I'm going to move on to question 5 now. So in question 5, a roadside wall has a zigzag pattern on it as shown. The two longest lines are each 2 meters long, and then the next two lines are 1 3/4 meters long, and each subsequent pair of the lines are 7/8 of the length of the previous lines. Find the total distance of the lines. Right. So, the two longest lines are 2 meters long. I'm just going to write 2 here and 2 here so you can see that. Okay. The next ones are 1 3/4 long and are 7/8 of the previous lines. Okay. So these are 1 3/4. Okay, and so forth. But to get from one of these numbers to one of these numbers, you times by 7 and 8. Right? Okay. Now, if I was to just sum up the lengths of these lines, the ones on the left, and then double them, that would make sense because there's two of them that you have to add all together all the time. There's always a pair of them. So, if I just write my series as 2 times of 2 plus 1 3/4 plus so forth, okay, that would make sense. So this will be my sum, right, of infinite terms, where the ratio here to get from one term to another is 7/8. So we're now going to do 2 times of the sum of all these numbers here, which we're going to use a limiting sum form for because this is between -1 to 1, right? So we're going to times that by 2 over 1 minus 7/8, okay, which is a over 1 minus r for the limiting sum formula. Okay, doing this on our calculators, or even in our heads if you wanted to. The bottom part is going to be 1/8. 2 over 1/8 means the same thing as 2 times 8, which is 16, and that will give you 32. Okay, so that's the total distance of the lines after we add them all together. The bottom part here is your homework, okay? But don't stress out too much about it. You don't actually have to do every single question there. As long as you do around half of those, okay, after your trials, that'll be okay. We're going to move on to recurring decimals and geometric series. So we can express recurring decimals as infinite geometric progressions and use a limiting sum formula to convert them into fractions. Question 1. Express the following as infinite GPs and use a formula for the limiting sum to find the values as fractions reduced to lowest terms. So, you might have learned how to do this a different way in the past, where you might have let x equals to 0.7 recurring, and you don't write this down by the way. You might have done this before, and then you times it by 10, so that becomes 7.777, and then you would do the bottom minus the top equation, so that gives you 9x equals to this minus that will cancel, and that will be 7 minus 0 now, which is 7. So x equals to 7 and 9. Okay, so you might have done that once before with me. But now what we've got to do is scrap that, and we have to actually do this using GPs. So, you know that this is going to be 0.7 recurring, so let me just write a few 7s like that. But I can separate each 7 there that's appearing in different place values by doing this. I can plus 0.7 was 0.07 plus 0.007 and so forth. It's going to keep going. There's more 7s. But what is the ratio from this term to that term to that term? It would be 0.1. Okay, you can just do that by getting 0.07 divided by 0.7. So if I multiply this by 0.1, I'll get to the next number. So now that I have that, okay, let me just reduce that down, put it here. I can use our limiting sum formula, where this is the first term. Okay, I'm going to write that up here, a over 1 minus r. It'll be 0.7 as our a value, and the ratio would be 0.1. So now I'll have 0.7 over 0.9, and you know by multiplying both top and bottom by 10, that will give us 7 and 9, which is exactly the same answer as this. Okay? Alright, let's go on to question B. So for question B, we've now got 0.27 recurring. Okay, let me write that down. So you have 0.27, 2727. We're going to separate these apart according to what's repeating. So we're going to write 0.27 first. Then for the next 27, it would have zeros to replace these two values. Then, followed by that 27. Then replace all these values here by zeros. I'm going to add another 27. And then it goes on. So now our a value is 0.27, but our ratio here, if you were to get the right number divided by the left, it would be 0.01. Okay, well basically dividing by 100, because it's moved 2 places, right, like that. to the left. So we're going to use our limiting sum formula, and we're going to again say that this is going to be 0.27 over 1 minus 0.01. Okay, and that would get us, double check, three out of 11. Right. Question C, 0.185 recurring. This is 0.185, 185, so forth. So let's break that up into 0.185, then replace all these values here by zeros, and follow it up by another 1.85. So that should add up to become what's over here. There's more numbers after that, so we're just going to write plus dot dot dot. Okay, so now our A value is this, but what's our ratio? It's going to be, let me just double check, 0.001. Okay, so the ratio is 0.001. Okay, which means divide by 1,000 if you read backwards, really. And you know that because there is a 3 extra zeros here, okay, before that 0, oh no, between that 0 and that 185. Okay, so this is going to equal to 0.185 over 1 minus 0.001, and that will get us 527. Question D. Now we've got a decimal that has some values at the beginning that are not repeating, meaning the 8.5. Okay? So this is actually 8.56666 and so forth. So these two numbers don't actually repeat. You can leave it there, take it out of that series, and now plus 0.06 I should say, starts from the 100th value, then plus 0.006, and so forth. So now a series that is geometric starts to appear. We're going to write 8.5 first. This is actually not going to be part of that series at all. It's not going to be the first term because the ratio from here to here, which is 0.1, is not a ratio from there to there. There's no ratio whatsoever from this number to that number. So your first term is actually this. This is your first term. Whereas your ratio here is 0.1 due to that extra 0 being put there. So we're now going to have a over 1 minus r, and a is 0.06 over 1 minus of 0.1. So 8.5 plus 0.06 over 0.9. Let me just double check that. Yes, I do get that decimal in my calculator. And when I write this as a decimal, I do get 8 and 17 out of 30 as a mixed numeral. Okay? And we're going to do the same thing with question E. So this will be 3.174545. Only the 4s and 5s repeat, whereas the 3.17 at the beginning stays put where it is. Okay, let's add the 0.0045 with a 0.000045 and so forth. Okay, 3.17 will stay put where it is. Now our value of A here is just that. Our ratio here, because there's the 2 extra zeros here that have been put there compared to the previous one. This will be a ratio of 0.01, okay, which means dividing by 100 or multiplying by 0.01. So our A value is Our A value will be 0.0045 over 1 minus the ratio which is 0.01. Doing that on my calculator. Let me just double check what that gets us. Yep, so it gets me that decimal. And as a mixed numeral, it will be 3 and 48 out of 275. And that's it for today's lesson.